Hello students, in this session let us solve this question of torsion. In this question it is given that two shafts of the same material and of same length are subjected to the same torque. If the first shaft is of a solid circular section and second shaft is of hollow circular section whose internal diameter is 2/3 of the outside diameter and the maximum shear stress developed in each shaft is same, compare the weights of the shafts. So in this question we are given with two shafts, one is solid and another is hollow. The same material is there, it means density is same length is there, also the torque applied is also same for both the shafts. The internal dia of the hollow shaft is 2/3 of the. In this question we have two shafts, one is hollow shaft, another is solid shaft, and it is given that both are made of same material. It means density of both the material is same. Density of solid is equal to density of hollow. Also the torque applied is same. The torque applies to the both the shafts is same. Torque applied on solid will be equal to torque applied on the hollow shaft. And also the length of the both shaft is given L. So length of solid shaft and length of hollow shaft is same. The hollow shafts, the inner dia is given that dia of inside dia of the hollow shaft is 2/3 of the outside dia of the hollow shaft. We have to find out the ratio of weights of the two shafts, that what is the weight of solid shaft to the weight of the hollow shaft for these conditions to be satisfied. This is our question. Weights of solid shaft to the hollow shaft, this we have to find out, right? So you should know that what is weight. Weight, when we say weight, that is equal to mg. Mg, mass into acceleration due to gravity, and that is equal to mass. But what is mass? Density multiplied by volume multiplied by g, rho vg, right? Density multiplied by volume multiplied by g. And what is volume? Volume is pi by 4. For solid shaft it is d square multiplied by the length, right? And hollow shaft, this will be d naught square minus di square, right? So this is how we will proceed. We will find out rho vg. So if we want to find out the weight, so you will get, we can simplify it, weight of solid shaft by weight of hollow shaft. When we say, it means that rho vg of hollow shaft, solid shaft, by rho vg of hollow shaft. And you know that the weights of two shafts is same, so we can write only volume of solid shaft, and density and g is same, density and g, because density is same material is there. So volume of solid shaft by volume of hollow shaft, this ratio basically we have to find out, the volume of solid shaft by volume of hollow shaft, right? And for that we want to find out the relation between dia of this and dia of this. So we should know the relation. For the given condition we will find out the ratio of diameters first, right? What is the relation between diameters, right? So here we have seen that the solid shaft by hollow shaft, that is equal to rho of solid v of solid g, that is equal to rho of hollow v of hollow and g, and density is same, so we can write v of solid by v of hollow, right? And what is volume? That is pi by 4 d square multiplied by L of solid divided by pi by 4 d naught square minus di square. This is the area multiplied by length of hollow shaft, and length is also same, pi by 4 cancel out. So basically weight ratio is given by d square by d naught square minus di square, right? D square by d naught square minus di square, isn't it? And you know that it is given that di is 2/3 of du, so we can write d square upon d naught square minus di is 2/3 of do. We can write 4 by 9 of do square. Di square is 4 by 9 of do square. So from here we can find out this is 9 by 5, right? So this will become equal to 9 by 5 d square by do square, right? So this is 9 by 5 d square by do square. So the ratio of weights ws by wh is basically given by 9 by 5 d by do whole square, right? So if we can find out somehow the diameter ratio, the diameter of the solid shaft, where d is the diameter of the solid shaft, and outer diameter of the hollow shaft, do is the outer diameter of the hollow shaft, then we can find out the ratio of weights, because weight ratio is nothing. For the given equation we have found out that this is come out to be this thing, right? So ratio of weights only. So ratio of dia only. We have to find out the ratio of dia basically now. And the torque of solid and torque of hollow is same. It means that what is torque of solid shaft? What is the torque of solid shaft? Torque of solid shaft, that is equal to, formula you should remember, the formula that T by J equal to tau by R, that is capital R, right? And because both the material are of same material, so tau should be same because material is same, so the stress at which they will be feeling will be same, right? So T can be written as, solving this, you know that polar moment of inertia, that will come out to be pi by 16. We have already done that. Torque in terms of shear stress is pi by 16 tau multiplied by d cube. So this is the torque of solid shaft. Similarly, we can apply the formula for torque of hollow shaft. That will come out to be pi by 16. Shear stress is same. D cube, here d cube is there. Here what will come out to be do power 4 minus di to the power 4 divided by do, right? So this is the torque of hollow shaft, and we can further simplify it. That di is 2/3 of do. So we can put here that torque of hollow shaft can be given as pi by 16 tau. Do we can keep as it is minus 2 by 3. 2 power 4 is 16 by 81 do to the power 4 divided by do. Solve it slightly and you will get 65 by 81. 65 by 81. So you will get pi by 16 tau. We are keeping it as it is because it will cancel out, and it will again multiplied by 65 by 81. 65 by 81 do cube, right? So this is the torque of hollow shaft, and from here we know that it is given that the torque of solid shaft equal to torque of hollow shaft. So we can apply the same condition here, that torque of solid shaft equal to torque of hollow shaft. Torque of solid shaft is pi by 16 tau d cube, and that will be equal to pi by 16. Shear stress will remain same, multiplied by 65 by 81 do cube, right? And from here we can find out the relation between d and do, that d of solid shaft will be equal to, find out the relation, other things will cancel out, and you will get a relation between d and do, and that relation will come out to be, d will be equal to 0.929, 0.93 do. So this is the relation between dia of the solid shaft to the dia of the hollow shaft, outer dia of the hollow shaft. Now we can find out the weight ratio. The weight ratio is given by this equation, 9 by 5 multiply D. D is 0.93 times DO divided by DO to the square. Solve it and you will get the ratio of solid shaft to hollow shaft. Try to solve it. DO will be cancelled out and you will get the final result. I am writing the final result. Solve it and get the final result, 1.55. So this is the answer of this question. So this is how we have obtained the ratio of weight of the solid shaft to the weight of the hollow shaft.